everyone. I am responsible for high-performance computing here at Riga Technical University. I will give a little overview what we are doing. Ilmārs already started about the e-infrastructures. If we look from science perspectives and HPC clouds, it is part of larger infrastructure which we can call e-infrastructure. It means that science in such infrastructure is done with electronical technologies, and as we see, cluster storages, databases, data, everything is in this infrastructure and is linked with networks and allows us collaboration, remote access, and so on. And in Technical University we also move into this direction. Little bit about history, how we are developing. So in previous century, in 70s, 80s, our researchers were working with mainframes, big computers, which could take several rooms. Researchers were waiting in real queues, working directly with these computers. But then with the collapse of Soviet Union, started personal computing era. Everyone was working with his desktop computer, and I think that such big scale computing was forgotten even. But then in mid-2000, with help of European projects, we started these activities again, and we started building what I call computing as a service, that our servers are in safe data center. They can be accessed remotely anytime. There is already installed all the software for researchers. There is support available and different services like HPC, clouds, grids. Here is our recent history. Everything started with Baltic Grid project. This project was aiming to build grid infrastructure in Baltic states. There were partners from Latvia, Estonia, Lithuania, and also several experienced partners from KTH, from Poland, 2 data centers, and from CERN. Project was quite successful in building infrastructure, in making contacts, maybe not so successful in bringing new users. Here is our team at the end of project with diplomas from project director. So, and by that time also in RTU was established RTU IT department who took over these activities, and later also RTU HPC Center was established, and so we are working in grid computing, cloud computing, and HPC as well. So here are our main goals. Our mission is to support our researchers from RTU to access e-infrastructures. We offer calculations on our cluster. Also, we allow collaboration with other universities through grid technologies. We provide access to scientific software, support, training. So, and currently these services are free for any researcher from our university, and we are open for collaboration with other institutions. I'm sure everyone here knows what is cluster computing, but maybe some words still that this is kind of computing we are doing here in Technical University. We have found that this is a more appropriate way for us this is something opposite to supercomputers with many parallel processors. Here we build cluster from several separate servers. There is head node, which is for job scheduling and resource planning, and these servers are connected with high-speed interconnection, and this is what it makes to be high-performance computing. Here's a funny picture. I think it's funny, but it's actually the way how it could be built. Of course, we use dedicated servers for that. Here are two pictures from top 500 how these computing systems develops in the world. This is list that shows the most powerful supercomputers in the world, and we see here is years how it develops in time, and we see the most systems currently in this top 500 are clusters. Smaller portion are massively parallel processing systems, which are those which consist of many processors and are very very strongly coupled. And other graph shows what are the most used interconnections, and we see that InfiniBand is most used, and popularity is gaining also 10 gigabit Ethernet, but InfiniBand can provide much smaller latencies. And with this I just wanted to show that this direction, cluster computing, where we are going, I think this is currently the right direction. Here is our computing system. It is not exascale, it's not petascale, it's it's terascale currently, but we are at the very beginning of our development, and currently there is also ongoing tender where we want to upgrade our system. This cluster, maybe it's not so powerful, but what we really want right now, it's a good storage system, high-end storage system for our current cluster and for new one. Of course, all this hardware is worthless without users and applications, and here's what our users are mostly using, starting from different programming languages and then in different science fields. And of course new users are coming, and we are helping them to bring their applications to HPC. This year has ended very long-awaited purchase. We have bought in university licensed softwares for all researchers, students, and for those who teaches, and these two are also available on our cluster systems, and our computing HPC Computing Center is taking responsibility to manage all those licenses. We provide one common place where everyone can sign up and get access to this software. So this is possible because all the licenses are network licenses, so it's easier to manage them. And our Vice Rector of Research already mentioned, this is our picture from our new data center. Its construction is almost finished. It's not opened yet because their hardware should be moved to this new data center. This is built with the help of European funds, and data center is located in a building next to us, but this data center will be managed by Ministry of Science and Education, not by RTU, but RTU will move all server hardware to this data center. So this data center is built for any academic institution in Latvia, so that all institutions can bring their servers to this data center. So the main server room is this one picture, is 70 square meters, 20 racks. There are also 3 racks for our HPC equipment. Here is not yet doors and roof, because this is cooling is made in such a way that there is a hot ISO. And also there are other room for equipment, also one room for future expansion. So I think it's very good for our future development. So that was shortly about what we are doing. Thank you.